one thing that we're going to bring together for this video is we're going to bring together our sine, cosine, and tangent and our Pythagorean theorem. So again, just everything playing together, but here we're going to find trig at a point on the Cartesian plane, okay? So we have the point 3, 4. We know how to plot that point. If we go to our Cartesian plane, we are going to go right 3 units, and then we are going to go up 4, okay? So we go right 3, so I'm here, and then I go up 4. How are we supposed to find trig at one point? Well, just like we've seen, we do trig with right triangles. So if I'm going to go right 3, and I'm going to go up 4, I just created this nice right triangle where my base is 3, my height is 4, I've got my 90-degree angle, and the theta that we're going to use for our trig is always going to be connected to the vertex, or the origin. The vertex is at the origin. So we're always going to create this nice right triangle. And like I said, we're going to be using the Pythagorean theorem. I need to know my hypotenuse. So to figure that out, I have 3 squared plus 4 squared. So that's 9 plus 16, which is 25. And that is equal to c squared. I square root that, and we get plus or minus 5. But since we're talking about distance here, we're going to go ahead and ignore the negative, and we know our hypotenuse is 5. From here, I can easily set up my sine, cosine, and tangent, right? Should feel familiar at that point, no pun intended. So we have the sine of theta. Again, theta is the angle with the vertex at the origin. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. That's it. Okay? All we got to do is take that point, build our right triangle, and then we can set up our sine, cosine, and tangent. So this one's a little bit more complex because we have this square root of 28. But we would plot our point in the exact same way. Wherever the square root of 28 is, I'm going to go that far right, and then I'm going to go up 6. And again, create my right triangle. Always put my theta where the vertex is at the origin. So I need to know my hypotenuse. So I take the square root of 28 squared plus 6 squared equals c squared. Square root of 28 squared is just going to cancel that square root, so I get 28. 6 squared is 36, and I get c squared. So 28 plus 36 here, that's 14, that's 64. And I square root both sides. C is plus or minus 8. Again, I'm going to ignore the negative because we're talking about a distance. All right, a couple things with this one, a little bit of an extension. I don't want to keep it in the square root of 28. We know how to simplify radicals, so we're going to simplify the radical. So factors of 28, that's 4 and 7. I square root both, so I get 2 root 7. Okay, so when I have sine, sine is opposite over hypotenuse, so that's 6 over 8, and we always reduce, so I get 3 over 4. Cosine of theta, that's adjacent, so that's 2 root 7 over 8, which will reduce to root 7 over 4. And tangent of theta, this one is 6 over 2 root 7, opposite over adjacent. That's going to reduce to 3 over root 7, and we have to rationalize. We don't want to keep that radical in the denominator, so we rationalize it, and we get 3 root 7 over 7. Okay? So all we're doing here is we're building our right triangle, finding our hypotenuse, setting up sine, cosine, and tangent. Make sure you fully reduce your fractions. Good luck.